Okay, we're going to look right now at confidence intervals in preparation for section 8.1. So confidence intervals, we're going to be looking at normal distributions, and we're going to be looking at values, a range centered at our mean. So let's take a look at a sketch of a normal curve. Our mu mean is at the center. So what we're interested in doing is finding an interval centered at the mean that contains a certain amount of the data. So we know from the empirical rule that if you go one standard deviation above and one standard deviation below, that this is 68% of the data. And this is from the empirical rule. And of course, we can get more specific because we have our Z table. So what we're interested in doing now is finding values, intervals, not just of 68% or 95%, etc., but of any percent centered at the mean. So let's say we're going to be looking at a confidence interval of 80%. So let's say we would like our interval to contain 80% of the data. So we have our mean in the middle, and what we're trying to figure out are what are the two Z values at the end. On our diagram on the right, the Z values here are 0 at the mean, -1, +1. So we're trying to figure out if we would like to contain 80% of the data, what are our Z values going to be? It's symmetrical, so you can see on the right it's -1 and +1. Our Z values are going to be opposites of each other as well. We're going to call the one on the left Z sub C minus, and here we're going to call the one on the right Z sub C. So how do we find these values on our table? Well, if this is 80% of the data, what we are not counting is 20% of the data. So the 20% that is not being counted must be at the two tails of the table. And since it's symmetrical, each of the tails must be half of that. So 20% divided by 2 is 10%. So each of these tails has 10%. So for example, this tail has 10% of the data. So everything outside that is 10%. Right? So here's 40%, here's the other 40%, and here's another 10%. The 40% on each side, so that gives us 80%, and then 10% on the two tails. We would like to find minus ZC and ZC. So we're going to use our Z table in reverse. So what are we going to look for? We're going to look for 10% on our Z table. So 10% is 0.10. The body of our Z table has 4 digits, so we'll use 0.100. So we're looking for 0.100 on our Z table to figure out what minus ZC equals. So minus ZC, let's look on our Z table now. Okay, I'm looking for 0.100. Here is the negative side of our Z table, and I see we have 0.00, 0.00, 0.01, 0.02, 0.04. Okay, let's look at these two rows that begin at -1.3 and -1.2. I see these rows begin with 0.09 and 0.11. I'm looking for 0.10. So I look at these rows and I see over here 0.1003 is as close as I'm going to get to 0.1000. This value is too small by 15 10,000ths, and this is too big by 3 10,000ths. This is the closest value here. What Z value is it? let's see, we are on the row that is beginning with 1.2 and negative 1.2, and the column we are in is 0.08. So the value we're looking at is z equals negative 1.28. Negative 1.28. That's not quite clear, is it? Let's just try that again. Negative 1.28. So that means our positive ZC is going to be 1.28. So if I go and I look at values for z's between negative 1.28 and positive 1.28, that is 80% of the data. So the probability that you're between negative 1.28 and positive 1.28 is 0.8 or 80%. We're going to be using this idea of confidence intervals in section 8.1. In section 8.1, you will not need to find these ZC values. We're going to be using the positive value, not the negative one, but of course they're just opposites. You will not need to find them, but I want you to see what they look like on the actual normal curve. These ZCs will be given to you. These are actually as part of your Z table. So let's look back at your Z table for a moment. And I'm going to look at the positive side of the Z table. If you look at the bottom, there are two more charts. We're going to be looking at this one that's begins with B. So what we just did is we looked for an interval centered at the mean, centered at mu, centered at z equals 0, that contained 80% of the data. Let's look at this row right here where my mouse is. 80% of the data, what ZC value? 1.28. These are the only critical values ZC that you need to know. And you don't need to memorize them, you'll have your chart. So let's just see again what they reflect. So let's say instead of looking at 80%, let's say I looked at 98%. This tells me that my ZC is 2.33. 98%, 2.33. So let's look at what that would mean in a diagram. So this means if I have a normal curve and I take an interval centered at the mean and I want this whole amount in the center to be 98%. This is my mean, so z equals 0. This ZC, the negative ZC over here would be negative 2.33, and this Z sub C would be positive 2.33. So you don't need to find these ZCs, these will be given to you on the table. Now you can look at how we are going to use these in section 8.1.